Alright class, we have the concluding part of the elastic properties of solid. Here we'll be using two questions to explain further how we can use Hooke's law to solve questions under the elastic properties of solid. The first one here, we have a load of 5 Newton gives an extension of 0.56 meter in a wire which obeys Hooke's law. What is the extension caused by a load of 20 Newton? Options, we have A 1.12 meters, B 2.44 meters, C 2.24 meters, D 2.52 meters. Now class, recall that we have three formulae under Hooke's law. The first one we have F equals to KE. Second one we have F1 all over E1 equals to F2 all over E2 equals to Fn all over En. And we have the third one, F1 all over L1 minus LO equals F2 all over L2 minus LO equals to F3 all over L3 minus LO. Now, we write out the given data here. We are given force F1, 5 Newton. We are given extension 1 is 0.56 meters. We are given force 2, 20 Newton. We are now asked to find the second extension. So the basic equation which will be suitable to solve this question will be F1 all over E1 equals F2 all over E2. So we input the given data. We have F1 to be 5 all over 0.56 equals 20 all over E2. We cross multiply. We have 5 times E2, which is 5E2 equals 20 times 0.56. We make E2 the square of formula. We have 20 times 0.56 all over 5. And when we push our calculator, we have 20 times 0.56 to give us 1.2 all over 5. And the final result, we have 2.24 meters. So our correct and final answer there is 2.24 meters, option C. Now, we have the second question here. We have to use the data to determine the length L of a wire when a force of 30 Newton is applied, assuming Hooke's law is obeyed. We are given the table. We have force 0, force 5, force 10, force 30. We have length 500.0, 500.5, 501.0, and we have length L. Now, the force F0 will give LO, meaning the body has not been stretched. We've not applied force to the body, which implies that length which the body will have when no force is applied on it will be the natural length, which is LO. We're saying our LO is 500 meters. When we apply a force F1 of 5, the body was stretched, having another length of 500.5. When we applied a force of 10, we have 501.0 as the length. Then when we apply a force of 30 Newton, we have length 3, which is that L that we are asked to find. Class, I said we can only equate two of those equations at a time. I can either use F1 all over L1 minus LO equals F3 all over L3 minus LO, or I use F2 all over L2 minus LO equals F3 all over L3 minus LO. I'm using the first one, and I want you to use the second one to practice if we are going to have the same result. Meaning, use F2 all over L2 minus LO equals F3 all over L3 minus LO to see whether we're going to have the same result. But here, I'll be using F1 all over L1 minus LO equals F3 all over L3 minus LO. So we impute our F1 is 5 all over 500.5 minus 500 equals our F3 is 30 all over L3 is L, which is the required length that we have to find, minus 500. Then everything will give us 5 all over 0.5 equals 30 all over L minus 500. When we cross multiply, we have 5 open bracket L minus 500 equals 30 multiplied by 0.5. This 5 will multiply through all the elements in the bracket. So we have 5 times L, 5L, minus 5 times 500 will give us 2,500 equals 30 multiplied by 0.5, we have 15. Now, 2,500 will go to the other side. We have FL equals 15 plus 2,500. When we add everything together, we have 2,515. So it means our 5L equals 2,515. We make L the solution formula. We have 2,515 divided by 5. When we punch the calculator, that will give us 503 meters. Plus, I want us to use the formula that has F2 all over L2 minus LO equals F3 all over L3 minus LO to see whether your result will be 503 meters. Thank you.